Okay, hey guys, welcome back. We're going to go over another related rates problem, the shadow problem. So here we got a spotlight that's on the ground, shining on the wall. It's 12 meters away. And we got a man that's 2 meters tall, about 6'6", walks from the spotlight towards the building at a speed of 1.6 meters per second. And we want to figure out how fast is the length of a shadow on the building decreasing when he is 4 meters from the building. So let's make sure we always start off with a nice picture, like geometrically speaking, so we can get an idea of what's going on with the math. Sounds good? Yeah, it's really cool. So we got a building. The wall of the building will be this. We got the floor of the building will be this. And we have a spotlight, which will be over here. This will be the spotlight. Spotlight. And this thing is shining on that wall. See, look at those bright lights. Ooh, it's powerful. It's shining on that wall, but there's a man in the way. This man is purple. It's a purple man, actually. Very, very unique. Might be an alien. He's walking towards the wall. He's like possessed, kind of, walking like in a zombie fashion, probably because there's Panda Express over there or something. And it creates a shadow when the spotlight shines on the man because it interferes by making this, mathematical relationship, this triangle, I guess. So from here to here, it's going to be the shadow, the length of his shadow, or the height of his shadow. So we'll call that y. Y is equal to the shadow height, shadow length. Yeah? And we're told that the man is 2 meters tall. So we're told that this guy is 2 meters tall. So he's 2. 2. And we'll say that the distance that the guy is from the wall is going to be x. So from here to the guy, that's going to be x meters away, or x meters away. And the distance from here to the spotlight will be 12 minus x because the total distance of this spotlight is 12 meters away from the wall. So let's, whoa. So let's do this first. This entire distance is 12. That's what's given to us at the beginning. So that means that if this is x, then this will be 12 minus x. Oh man, 12 minus x. Hey guys. All right, so we got some math going on here. And we need to figure out the answer to this question. We're told that he's going towards the building at a speed of 1.6 meters per second. So his change in x, dx dt, don't mind that, dx dt is equal to negative 1.6 meters per second because he's moving to the left. He's moving in this direction. And x is, to the right, x is positive. To the left, x is negative. Oh, here we go. Got it. And we need to find the change in the shadow height when he is 4 meters from the building. So we need to find dy dt when x equals what? When x equals 4. 4. This is our goal. We need to figure that out. What's dy dt when x equals 4? Got it? Cool. Okay, so what we're going to do is, there we go. What we're going to do is use the beautiful relationship of similar triangles because here we got the big ass triangle, the big triangle. We have the big triangle like this. Big triangle will be like the big triangle will be. Can you all see that? Yeah. I want to make sure I don't run out of space. I'm going to make sure I use all the space I can. So the big triangle, the left side is y, and this base is 12. Okay, this is the right triangle. And we have the small triangle in here. What the? This thing's almost dead. Anyways, this small triangle with the guy on the left. This side will be 2. This base will be 12 minus x. And these are going to be similar to each other. Swiggly, similar. So we can relate these two triangles in an equation by just doing something like y over 2 equals 12 over 12 minus x. So let's do that. Let's do y over 2 equals 12 over 12 minus x. You can also do like y over 12 equals 2 over 12 minus x. It doesn't matter. It all works out the same. So solving this, or rewriting this in terms of just y, we'll have, actually let's go up here. We'll have y times 12 minus x is equal to 12 times 2. 12y minus xy equals 24. And from here, we can find the derivative by using implicit differentiation. So we'll go 12 dy dt. dy dt minus x dy, so dx dt times y. Remember, we're going to use the product rule here. So derivative, keep that the same, plus then take the derivative, or keep the x the same now, times the derivative of y with respect to t. And then the derivative of 24 will be 0 because it's just a constant. Okay, and we can then do, I'm trying to think where I should put this. Let's go one more line over here. So let's solve this for dy dt. Okay, so let's bring the dy dt to the left. So we'll have dy dt times 12 minus x minus dx dt on the left. But we can just add this to the right, so we can just save, so we can save ourselves a step. So again, minus dx dt times y. Let's add it to the right, so e is equal to dx dt. Let's keep it in red, actually. Well, actually, no. Let's keep it like dx dt times y, just so it stands out. Right. So I grouped the 12. I grouped the dy dt. Took these two out over here, and then I'm going to divide by the 12 minus x. Minus x. These will cancel, and we'll get. Hey guys, we'll get that dy dt is equal to dx dt times y. What the? Over 12 minus x. 12 minus x. Okay, we can see that. Kind of squeezing that in here. So then we have an equation for dy dt. Now we just got plug and chug. Now we have a value for x. We have 4. We have a value for dx dt, which is negative 1.6. But we need to find a value for y. So what we can do is just figure out what y is when x is 4. Because we're looking when x is 4. So when x is 4, let's look at these two triangles here. Or we can just look at this. I mean, if x is 4, then we have that y over 2. Well, let me do it. Y over 2 equals 12 over 12 minus 4. Y over 2 equals 12 over 8, right? 24, so y is going to then equal 224 over y equals 3. So y equals 3. So we just plug this in into here. So we get dy dt equals negative 1.6 times 3 over 12 minus 4. And we get that negative 4.8 over 8. Let's do the math. So 1.6 times 3 divided by 8. 0.6, so we get negative 0.6. Negative 0.6 meters per second. Woo! What the? Woo. Man, doing calculus is tiring. What do you think, Panda? That was awesome. Yep, it was. All right, so I hope that helps. I'm sorry about the little messiness. I always forget how big I write, but let me know if you have any questions or if you have any feedback. I'm always trying to improve. And of course, if this helped you, please subscribe and give me a like and tell your parents, tell your family, tell your enemies, so tell everybody to subscribe and let me know if you have any ideas for any videos you would like in the future. See you guys next time.